It's Billjessm here in my wonderfully dirty garage. Today I want to tell you about weight reduction and how carbon fiber can actually make your car go faster. You might say to me, "Hey, Billjessm, what the hell do you have going on here?" Well, this, my friends, is physicist's proof that acceleration is increased by decreasing the mass. I've strictly stolen this from Engineering Explained. You guys should check him out. He's quite incredible, I must say. But it says here that you have a 2,500-pound car, which is, average. You have 100 pound-feet of torque across the whole torque radius, which really isn't all that possible, but just for simplicity's sake, we'll say that it is. You have a 12-inch tire radius and a 6-to-1 gear ratio. So, Isaac Newton, the most extreme physicist on the planet, says that force is equal to mass times acceleration. So therefore, acceleration is equal to force over mass. Your torque at the wheels is equal to your torque times your gear radius, or your gear ratio, I'm sorry. So you have 100 pound-feet of torque times your gear ratio, which is 6. So you have 600 pound-feet. Your force at the wheels, torque is equal to force times the diameter of your wheel. So you have 600 pound-feet is equal to your force times your diameter, which is 12 inches. Now we want that to be in feet. So we divide it by 12, and it gives you, well, 1. So your force is 600 pounds at the wheels. So we now have our force. So acceleration is equal to force over mass. You have a 600-pound force over 2,500-pound mass. So you have an acceleration of 0.24 g's. Now 1 g is equal to 32.2 feet per second squared. So therefore, your velocity is equal to your acceleration over time. So you want to go 60 miles per hour. Well, you have 60 miles per hour, which is equal to 0.24 g's times your time. Now, we want to know what time is, so we would take 60 miles per hour, which is about 88 feet per second, and divide it by 0.24, which is 32.2 feet per second squared, which gives you 11.4 seconds. So, let's say you add carbon fiber. Now, for 50% fiber by volume of epoxy, carbon fiber has a density of 0.058 pounds per inch cubed. Steel has a density of 0.282 pounds per inch cubed. So by volume, steel is almost 5 times heavier. So you take off 500 pounds from your car using carbon fiber, which is pretty easy to do. If steel is 5 times heavier, just replace a bunch of stuff. Well, we'll do the same equation. You have your acceleration is equal to your force over your mass. Well, you have a 600-pound force. Now you only have 200-pound mass, or 2,000-pound mass. So therefore, you have 0.3 g's. Now remember, 1 g is 32.2 feet per second squared. So you have 88 feet per second over 0.3 times 32.2 feet per second squared. So therefore, it takes you 9.1 seconds. So, if you lose 500 pounds from your car using carbon fiber, you will gain an acceleration of 2.3 seconds. That's pretty impressive. So, you will be even closer to that 10-second car that you've always wanted. And get this, carbon fiber, according to BBC Engineering Connections F1, said through a testing that a steel drive shaft will snap at 1,014.9 pound-feet of torque, whereas a carbon fiber drive shaft will snap at 3,487.2 pound-feet. That is really impressive. Major impressive. So not only is carbon fiber a lot stronger, it's a lot lighter, and you'll go faster too. What's not to love about that? Well guys, that concludes my video for this week. Next week I will be doing the same thing, only in metric units. So for you people who don't follow the Imperial system, such as myself, which is Canadians and Europeans and, you know, lots of other people. Most of the people that use the Imperial system are American. And frankly, the American system works, but it's not that great, in my opinion. Just saying. Don't hate, appreciate. Anyways, I'll see you all next week. Also, I will include in the description a link to Engineering Explains' really awesome YouTube channel. He is friggin' phenomenal. You guys will love him. He explains everything you need to know about a car in depth and scientific proof that you need to know. So, if you have any questions or comments, please link it in the description or your comments section below. And I will see you guys next week.